Hello everyone. In last class we discussed about cement. What is cement? What is the composition of cement? What is the composition of Portland cement? How to manufacture Portland cement. Continuation topic is setting and hardening of cement. Before going to discuss about setting and hardening of cement, we need to revise the third step of the manufacturing of Portland cement, that is burning zone or clinkering zone. Whenever we prepare the Portland cement, here clinkers are formed. What are the clinkers? Dicalcium silicate, tricalcium silicate, tricalcium aluminate and tetracalcium aluminoferrate. These are the clinkers which are present in Portland cement. Okay, to that Portland cement, which consists of dicalcium silicate, tricalcium aluminate and tetracalcium aluminate, aluminoferrate. For this we have to add water. That means whenever we add water to cement, these elements will involve, or the chemicals which are present in Portland cement, these four will react with water. You should remember that point. Look into our most important topic, most important long answer question for external examination, that is setting and hardening of Portland cement. What is setting, what is hardening? First you need to understand. In examination point of view also, whenever you get this question in examination, first you need to define what is setting and what is hardening of Portland cement. Look into the topic now. Portland cement on mixing with water is converted into a paste. At the time of introduction of Portland cement, we discussed about this. Portland cement is also called as magic powder because whenever we add water to Portland cement, it can form one type of plastic mass. That plastic mass is called as cement paste. Okay, hydration reaction result in the formation of gel and crystalline products. You should remember one important point here. If you understand this point, you can understand the setting and reactions and hardening reactions very easily. Whenever we add water to cement, it can form cement paste. This cement paste, that means which is in the form of plastic mass. At that time, that cement undergo two types of reactions. One is hydration, another one is hydrolysis. Okay, so first reaction starts whenever we add water to cement. Hydration reaction takes place. Hydration is nothing but absorption of water molecule is called as hydration. Reaction with water molecule is called as hydrolysis. At the time of introduction, we discussed cement is hydraulic in nature. Hydraulic means the cement which whenever it reacts with water, it will undergo both hydration and hydrolysis reactions. Okay, so whenever we add water to cement, the reaction will starts with hydration, then it results in the form of gel. First gel formation takes place. Whenever we add water to cement, it will form one gel and it will be converted in the form of crystalline product. You must remember these 2 points. Look into the definition of setting. Stiffening of the original plastic mass due to the initial gel or internal gel formation is called as setting. Just now we discussed about that. Whenever we add water to cement, first it will form gel, then it will form crystalline product. That internal gel formation is called as setting. So what is setting? Stiffening of the original plastic mass due to the initial gel or internal gel formation is called as setting. Next, hardening. What is hardening? The development of strength due to the crystallization is called hardening. Okay, here development of strength due to crystallization. Whenever we add water to cement, first it will form gel, then it will be converted in the form of crystalline product. The gel formation is called as setting. Crystalline product formation is called as hardening. Initial setting of the cement. Okay, paste is mainly due to the hydration. Paste is mainly due to the hydration, absorption of water molecule. Just now I said hydration is nothing but what? Absorption of water molecule. Tricalcium aluminate and gel formation of tetracalcium aluminoferrate. We have three: tricalcium aluminate, dicalcium silicate, tricalcium silicate and tetracalcium aluminoferrate. Among four, which will involve in the reaction initially? Tricalcium aluminate will involve in the reaction. Observe the reactions. Only 4 reactions are there. 4 reactions are very important. In examination point of view, we can explain the setting and hardening reactions by using these 4 simple reactions. Why I am using word simple means here only hydration and hydrolysis reactions takes place, which is very easy to remember and which is very easy to write in examination. Look into the first reaction, setting reaction, initial setting reaction. So among 4, which will involve in the reaction initially? Tricalcium aluminate will involve in the reaction initially. This tricalcium aluminate absorbs 6 moles of water molecule. Absorption of water molecule is called as what? Hydration. Here C3A undergo hydration. Observe the reactant side and product side. Here we are just adding 6 moles of water molecule. In this reaction, it is the exothermic reaction, that is why it is releasing energy. How much amount of energy it is releasing? 880 kilojoule per kg. It is called as, this product is called as hydrated tricalcium aluminate. Tricalcium aluminate reacts with water and it will be converted in the form of hydrated tricalcium aluminate because hydration reaction takes place here. Next, initial setting reaction along with the C3A, that means tricalcium aluminate, C4AF, that is tetracalcium aluminoferrate also involved in the reaction by absorbing 7 moles of water molecule. Observe here, we are that means this tetracalcium aluminoferrate react with water and it will absorb 7 moles of water molecule and it will be converted in the form of crystalline product and gel. It also releasing energy, that is 420 kilojoule per kg. So this is about initial setting reaction. Initial setting reaction starts with the hydration of tricalcium aluminate, tetracalcium aluminoferrate. It will ends with the hydration as well as hydrolysis of dicalcium silicate. Observe here, initial setting and hardening also due to the hydrolysis of dicalcium silicate and form tobermonite gel. Just now we discussed about that setting is nothing but gel formation. Here setting reaction also involves hydrolysis of dicalcium silicate. So setting reaction involves what? Tricalcium aluminate, tetracalcium aluminoferrate both undergo hydration. At the same time, dicalcium silicate undergo hydrolysis. Okay, actually they are telling hydrolysis. Here, whenever we observe the product, here hydration, first product is hydrated product, second product is hydrolysis product. So, in this third reaction, hydration as well as hydrolysis takes place. Look into the reaction. Dicalcium silicate reacts with 7 moles of water molecule and it will form tobermonite gel as well as crystalline product. Here it also releasing energy, that is 280 kilojoule per kg. Next, final setting and hardening reaction involves hydrolysis of tricalcium silicate. Observe the last reaction, tricalcium silicate is there. This tricalcium silicate react with 6 moles of water molecule and it will form tobermonite gel and crystalline product. Whenever we observe the third reaction and fourth reaction, products are same. Only the difference is water molecule. Here 6 water molecule, here 3 water molecule. Here 1 mole of calcium hydroxide, here 3 moles of calcium hydroxide. Here due to the difference in the water molecules, we are getting different composition of same product. Product is same but composition is little bit different. That is only the change. We can observe. Here also energy is released. Here 500 kilojoule per kg energy is released. So whenever we look into the 4 reactions, First reaction, this is the first reaction. In first reaction, tricalcium aluminate undergo hydration. In second reaction, tetracalcium aluminoferrate undergo hydration. In third reaction and fourth reaction, hydrolysis of tricalcium silicate and dicalcium silicate takes place. So this is about the reaction. To understand this reaction, this flow chart will help you a lot. What is this flow chart means? First we are adding water to cement. Whenever we add water to cement, within 1 day, hydration of C3A. C3A means what? Tricalcium aluminate. And C4AF. C4AF means what? Tetracalcium aluminoferrite. So whenever we add water to cement, it will form within 1 day. How many reactions takes place? 2 reactions. Among 4, 2 reactions takes place within 1 day or after 1 day. That is hydration of tricalcium aluminate and tetracalcium aluminoferrate. Then after 7 days, gelation of C3A and crystallization of calcium hydroxide takes place. That is third reaction takes place. Here in setting and hardening of cement, 4 reactions are there. First reaction, second reaction, third reaction, fourth reaction. To remember these 4 reactions, this will help you. First reaction, that means in first step, these 2 reactions happens. In second stage, this reaction happen. In third stage, that is after 28 days, this reaction happens. That is gelation of C3S and C2S and crystallization of calcium hydroxide. This is about setting and hardening of cement. So for setting 7 days it will take. For hardening it will take 28 days. Observe the one more flow chart. Whenever we add cement to water, first it will form what? Plastic mass. Then it will be converted in the form of metastable gel. Then it will converted in the form of crystalline product. Finally, these both are converted in the form of crystalline products. So here gelation, gel formation is called as setting. Crystalline product formation is called as hardening. So this is about setting and hardening of Portland cement, which is very important for external examination.